Well, hi everyone. So thanks for joining our Back to the Future event. Look, we had quite a number of questions that were given to our customer guest speakers, but we also had an overwhelming number of questions for our Futurist guest speaker or keynote speaker, Shara Evans. So consider this as a bonus video. I've got some exclusive time with the great Shara Evans. And so with that, we are going to just kick off the questions here with you, Shara, if you don't mind.
Go for it now.
Indeed. Thank you, Shara. So the first question is a two-part question. So with the rise of deep fakes, how can identity be protected in a VR meeting, Shara?
Oh, look, this is going to be one of the questions that is fantastically challenging. And I think that the way we're going to do it is using artificial intelligence and pattern recognition and biometrics. So if I think about deep fakes, what you're doing is you're actually, if you like, skinning a video of someone and putting it onto an actor. But no matter how good the actor is, even if they're somebody like Alec Baldwin, who's pretending to be Donald Trump, his mannerisms are going to be slightly different than the real Donald Trump. And this is with a trained actor. With most deep fake videos, they're not trained actors who are doing this. They're other people. So if you've got pattern recognition and you've got really good biometrics that actually understand how people gesture and how they move their face and their hands and posture and all these other different biometric, unique individual markers, and AI is analyzing it in real time, then you start to get a way that you can detect in real time whether it's the person you think you're talking to, whether it's a deep fake, or even in the metaverse, because that's, I think, a question that other people have asked as well. So I think that's going to be a big part of the solution. And as we get into this world of quantum computing, remember that our computers are going to be really, really powerful, and that's going to allow us to do this in real time.
Wow, so I think you've answered the second part of this question slightly, but I'll ask it anyway. So perhaps with this then, how can you trust the voice of the Metaverse avatar you're speaking to, especially if they're your co-worker or client, and ensuring that they're not a malicious actor?
Well, that's actually a little bit different, because if you're talking about a Metaverse avatar, I could look like I'm a cat, or I could look like I'm a cartoon character. And that's a lot harder because you can't use AI to pick up, let's say, the gestures of a person, or the unique things that a person would do, because there's nothing for them to really compare it against. Where you would be using AR to check the avatar would be more in terms of looking at the words used, like the specific words. Is it the language and the cadence of one's voice and the tone of one's voice that the real person would be using? Does that match the avatar? Then you can start to do, again, this biometric pattern recognition in real time, but it's a different aspect of that pattern recognition.
Thanks, Shara. I stand corrected with that second part of the question.
That's okay.
Thank you. Moving on to the next one. How do you see encryption and authentication working in the future once quantum computing becomes more mainstream?
Well, number one, once quantum computing becomes mainstream, today's encryption is going to be broken in no time flat. That's the bad news. The good news is that cybersecurity researchers all around the world in lots of different companies and in research labs are working on quantum-based encryption. And I've actually talked to quantum physicists about some of the really weird and wonderful and wacky ways of using encryption, including micro wormholes, putting encrypted stuff down micro wormholes to be able to protect the sovereignty of information. Like that's how weird and wacky it might get into the future. So even though we might destroy today's encryption, I think coincident with that, we're going to have other new ways of encrypting.
Well, so insightful. Shara, I've got the next one here for you. Do you have a view on when we might reach a level of general AI as opposed to today's level of narrow AI?
That's such a great question. And even AI researchers are really divided on that answer. Today's AI solutions that you would buy commercially are very much narrow AI focused on doing specific things. Although there are researchers that are looking very heavily at how do you start to train AI to multitask like us humans do. And the key here, I think, is when quantum computing starts to become mainstream, then AI is going to have enough computing juice to be able to start doing that. Now, researchers a few years ago, before some of the latest quantum advances, were figuring 2050 to 2075, depending on how fast or how slow quantum computing becomes a reality. I think that's going to dovetail very closely into when AI is able to multitask. Now, multitasking is not the same as general AI being able to do everything that a human does. So it's going to start with being able to do multiple things and then start to branch out. But I think that for the foreseeable future, and I'm talking decades, we're going to need humans in the loop because AI, the bigger that neural network gets, the more obtuse it is to researchers and the more chance there is for something to go really, really, really wrong.
And I definitely like that picture with humans still in it, Shara. Absolutely. Using your example of the chip in a soldier's head and noting that cyber vulnerabilities are always found and exploited, how can we ensure that chips aren't exploited by the enemy or by enemy soldiers to cripple their force?
Well, that's such a good question. So let me go back to medical devices in general, because that's where, we would probably start using chips. Today with medical devices, just about every implantable device has some sort of wireless access, but it's actually near-term wireless access. So if we had chips that presumably you would want wireless access because you don't want to have to do major surgery on your brain every time you do a software update. That would be kind of ridiculous. But if you keep it to something that's in close proximity, there's less likelihood that it can be hacked. However, if we get to the stage where we start connecting our brains to the wider internet, then all bets are off. How in the world are you going to protect any endpoint that's connected to the wider internet from potentially bad software updates or hacking or any of the other things that happen in the cyber world today, but that chip just happens to be in somebody's brain as opposed to in a computer or in an IoT device?
God, thanks, Shara. This one's a bit of a mouthful, so just bear with me. So much of the attraction of the metaverse is an alternate reality. How will one manage identities and privacy when a core feature of the metaverse may take an alternative identity and potentially participate in activities that one may not consider in the real world?
Again, that's an area of the wild, wild west. Right now, the metaverse is so new, and it's not just one metaverse. There's, Facebook's version of the metaverse. There's somebody else's version of the metaverse. And the answer is going to be different in every one of these different digital realities. But the bottom line is that if you're creating a fake persona that acts in ways that you or I don't act in the real world with our real persona, how can you protect that? The answer is maybe you can't, but then maybe you can use some of the AI tools that I described earlier. But more importantly is if you've created a fake persona to play around in the metaverse and that fake persona gets compromised, what are the real world implications? Well, maybe your gaming experience isn't as much fun, but actually, so you're disappointed, but who cares? That's not actually catastrophic. I'm much more concerned about our real world persona being compromised by something that we may do in the metaverse than I am about a fake persona that we might have.
Indeed. And we've got time for one more, Shara.
Sure, go for
it. The last one is, what software or options are out there to help detect a deep fake?
Well, I've mentioned a lot of techniques already that can be used theoretically to detect deepfakes. And I know for sure that there are a lot of AI researchers that are taking these and similar concepts and playing around with them in research labs. But I'm not familiar with any particular solution that's an off-the-shelf solution that you can buy today.
Indeed. Well, thanks for answering that one. I know it's a bit of a cheeky question.
Yeah, but it's a good one.
It's a good one. Oh, absolutely. I would have tried that one. So, Shara, that's all we had time for today. Again, thank you for joining the Back to the Future show. And hopefully we can have you back on once again in the future.
I would love to do that. And thanks, everyone, for asking such great questions. I really enjoyed this.
Indeed. Thanks, Shara. Take care.